Hello folks, and welcome to this video. We're going to combine a couple of things today, looking at black body radiation, and we're going to use the PhET Black Body Spectrum app for that. And we're going to then take data using this and then analyze that data in Excel. So we'll just get started by sort of thinking about what the experiment we're interested in. We're interested in the effect of temperature, the black body temperature, on a couple of variables. You'll notice that at peak rises, okay, and so does the area under the curve, and that's shown by this number here, in this case 5.77 times 10 to the 7 watts per meter squared, so it's an intensity. But we're also looking at this value of the peak wavelength, okay, so if I just click on labels here and graph values, you can hopefully see here that as I move the temperature down, that peak appears to go to the right. So we're interested in a value of x of that peak. So I've taken some of the data here. I've changed the temperature value, and each time I've measured the temperature in Kelvin, of course. I've measured the value of the maximum wavelength. I've used W here, which isn't great. And then I've also put in I total. So I'll just finish that off. Okay, we'll take one more data point here, or two more data points here. We've got 9,000, it's a bit fiddly to get there, 9,000. Okay, so that gives me a peak wavelength here of 0.322, and then we had 3.72 times 10 to the 8. Okay, so 0.332, I'm just confirming that number of the 3.72 times 10 to the 8. Now in Excel, if you want to put in times 10 to the 8, all you have to do is press 3.72 E8, and that will come up as times 10 to the 8. We'll just finish off our data taking here. Okay, so we've got a huge number of data points now. 10,000. Okay, you can see my peak has gone to 0.290. And then we also had a peak intensity of 5.67 times 10 to the 8. Okay, and that's our values that we need. Notice a couple of things there. Okay, those E's stay there. Don't worry if there's an E in there, that's still going to be processed by Excel. And also there's something a bit odd here. Okay, when we put in a 0 in Excel, then it kind of ignores it, even though it is significant. In an IA or any kind of experimental report, you would keep that 0 in there. I'm sure there's a setting on Excel somewhere where we can change that, but I'm not worried about that today. Let's look at relationships. So let's take the relationship, for example, between temperature and the wavelength. You can notice there that we've got temperature going up and wavelength going down. The way that we would analyze that is obviously through a graph, so let's do that. Okay, we're going to analyze graph. Notice I've selected those two data streams there. I'm going to go to scatter, and I'm going to get a graph now. Obviously there's a lot of things wrong with this, there's no labels. We're not going to worry too much, but there you can see that lovely correlation between our peak value of the wavelength and the temperature. Now, the nice thing about Excel is it's able to do a lot of the analysis for you. Okay, and I'm going to show you how to do that. If I click on my series of data and I right click, I can then add a trend line. All right, and notice it automatically takes you to do a linear trend line. Now, what I'm going to suggest we do, we could play with a bunch of these. Okay, what Excel tries to do is find the best type of trend line it can. So if you choose an exponential, it says, okay, I'm going to try and produce an exponential. Okay, it will produce a linear, it will produce a logarithmic. What I'm going to suggest we do is, in fact, we go for a power law. Okay, notice there, that line is really nice. It says what's called a low R squared value. And again, we can talk about that later. It means it's a good fit to the data. If I then press display equation, frustratingly, it's hidden there by the data, so we'll just move it up. Okay, you can see there that we've got a power law, which is Y, that's our lambda max, W max in this case, is equal to some constant number times X, which is the temperature, and then we've got this here to the power of something. In this case, it says to the power of effectively minus 1, right? Minus 0.996. Well, that means that we've got really a power of minus 1. Okay, and what that means is that this is this inversely proportional relationship that we've been talking about. Now, you notice there, it's really simple. Just to do that, all we had to do was fit our power law to it, and it comes back with a number. Now, what you're looking for in physics is whole numbers or half numbers here. So you're looking for 1, 2, 3, 4 even, okay? Or maybe to the half, to the 3 halves, to the 5 halves. Generally, those are the kind of numbers that we're looking for. And so if you've really discovered a law, then that would be indicative in terms of knowing whether your numbers are right or not. All right, now, your job is to take your temperature versus intensity data, okay, and try and find the power law for that. And if you're happy to do so, all right, simply just select the data, hold the, hold on, I pressed the wrong button there. Hold the control button. That will allow you to select all of these guys at the same time, as long as you keep on holding that control button, insert, and then put your graph in as well. Okay, so I'll leave that as an exercise for you to do. You can fit your power law to that and see what the relationship is between the intensity and the temperature. Good luck.